So today we'll be looking at a university guideline on physics practical, and today we'll be learning how to label your graph, how to title your graph, how to get your best fit graph, and how to scale your graph. So let's start with how to label our graph. So recall in secondary school we have something like this, I have something like this in our graph sheet, and we have here will be labeled y, and here will be labeled x. And let me say we plot the gradient line, and we have something like this as the slope or the gradient, and we have n. Now this is mathematics in secondary school, but in university we don't do this. We don't do this. We are not saying it's wrong, but we don't do this. Instead, we give the quantity of what we are plotting and their units. We give the quantity of what we are plotting and their units. So let's say we are plotting a graph of t. Let's use a simple pendulum for instance. T squared against L. T squared against L. Now, T squared is in second square and L is in cm. Very important. So how do you label this graph? How do you label this graph? You clean this, you clean this. So how do I label this graph? This will be t square bracket open, x square bracket close. And here the horizontal will be L C in centimeter bracket close. And this is the proper way to label your physics experiment. You don't use y and x, you use the quantity and the unit. Now let's take another example. We say we should label a graph, or we should title a graph, and say log t is plotted against log L. So how do we title, or how do we label this graph? We say L. This is your graph, and we say log t L. There's no unit in log. Log t against log L. Very important that you can draw your slope anywhere on your gradient line. And that's how to label our graph. For example, they say plot a graph of h t squared against h squared. So meaning that if we are having a graph like this, and we are having it, let's assume it's coursing through the intercept. So we have something like h t squared against h squared. So this is how to label the graph. Very important. This is wrong. This is wrong. I have a graph of log t against log L, and I need to title this graph. So this is the proper way to title your graph. A graph of log t against log L. Now this is the proper and the standard way to title your graph anytime you are plotting. This is the standard and the proper way to title your graph anytime you are plotting. This is for this. This is for this. Now I want to title this graph. The graph of t squared x squared against L in centimeter. Please note, in straight line and above your graph. Now I want to title this last one here. So let's title this graph. A graph of ht squared against h squared. Note, Sometimes they don't give you guys units in when plotting your or when tabulating your ht square and h square. They don't give you guys. Once you see that there's no unit in the table, you don't need to put units. But once there's units, like the first one we did here, s square, t square, s square, L in centimeter, make sure you put your units. Best fit graph and scaling. Best fit simply means balanced graph. Let's say that we have a graph of t square in second square against L in centimeter square. Please, this is not how to title your graph. Very important. So I have something like this. In plotting that graph, I have 6 points on the table. 6 points on the table. 6 points. Let me assume this point passed through here, 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 and here. Now, how do I get a best fit graph? I'm using the board, so it might not be having a very straight line. So consider that. So I have something passing through here, where one side, one point to be out and the other point to be out. This is known as balanced best fit graph. It's known as balanced graph. Now, this one is out, this one is out. Or let's say, for example, I have something like this. I have 6 points, still 6 points, and one is here, one is here. This is still a best fit graph, where 2 is left, 2 is left out, 2 is left up. It is called balance, meaning that it's just 2 that is entering and it is in a balanced condition. Now, this is not a best fit graph. Let me assume I have another point. Let me assume I have another point. And I have another point. And somebody decides to draw this. This is wrong. This is completely wrong. This is not a best fit graph. The best fit graph is a graph where the points are balanced when drawing the gradient or the slope. Make sure that if you are drawing the gradient or the slope, 2 is left out, 2 is left up, or 1 is left down, 1 is left up. That's how you know a best fit graph, to get a proper slope when solving. Now that's for best fit graph. Now the next one we'll be talking about is scaling. Scaling, very important. You need to know that your scaling, remember I say your title should be up. So let's take for example, this is a graph sheet. Let's take for example, this is a graph sheet. This is a graph sheet. Typical example of a graph sheet. And up here, let's say we should plot a graph of L in centimeter against T square in second square. So let me title this graph. A graph of L in centimeter against T square second square, T square second square. And that was the first one. You decide to underline or note. And this is your graph. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have another one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, each of these bold lines is 1 centimeter in your graph. Each of the bold lines, if you check your graph, you see it. Each of these bold lines is 1 centimeter in your graph. And each of these bold lines is 1 centimeter in your graph. Let's take for example, you want to do this scaling. Please, the title should be up. The scale should be down. Now, how do I scale this? Let me assume you are using 1 centimeter to represent 2 units. And we have something like 2, 4, 6. We continue. That's on the vertical axis. Remember, this is my L in centimeter. and this is my HT in second square. So, and we say on the T square axis, let 1 centimeter or let 2 centimeter represent 5 units. For now, I'm using 1 centimeter. So we have 5, 10, 15. This. How do I scale this? Let's start. First of all, you write scale. Let 1 centimeter represent 2. Now, instead of putting units, the quantity here has a unit. Instead of putting unit, the quantity has a unit. So you put 2 centimeter. It's not units, it's 2 centimeter. The unit here is centimeter. So always use the quantity and the unit. So we say 2 centimeter. Let 1 centimeter represent 2 centimeter on not y axis, not y, on L bracket open, MC bracket close axis. And this is the standard way to write your scale. This is the standard one. Let's do for the horizontal. L. Let 1 centimeter represent 5. What's the second square on T square bracket open, S square bracket close axis. And this is what you'll be using throughout your school year as a university student. This is this is what you'll be using. It's a standard way of writing your scale. It's the standard way of writing your scale. So please take notes.